All right, guys, so in this video, we're going to go over the graph of the parent function for sine. So it says, use your unit circle to graph y equals sine of theta in the interval negative 2 pi less than or equal to theta less than or equal to 2 pi. Use radians as the input and the trig function as the output. Then identify the domain, range, amplitude, and period. So if we sketch kind of some of the key points in sine, right, from the unit circle, we know that it starts at 1, 0, or 1, 0. We know that it has a max of 0, 1. Negative 1, 0, and then a minimum of 0, negative 1. Okay. Now we know these unit circle values here in terms of radians. Our angle measures are going to be 0 radians, pi over 2. This is at pi, where it's a negative 1, 0, and then at 3 pi over 2, we're at 0, negative 1. Okay, so remember sine is the y coordinate for each of these values, right? So we're going to graph our values here, 0 at x equals 0, right? The input is radians. The output, actually, let me put it in blue. Radians as the input, and then the trig function as the output. So I'm plotting the points here on the coordinate. At pi over 2, we're at 1. This is at negative 1 here. Pi, we're at 0. 3 pi over 2, we're at negative 1. And then 2 pi, we're back at 0. So this, and you'll see that if you were to graph y equals sine of theta, it's not like a linear type thing like that. There's a curve to it. So we're gonna go like a sine curve. And it's actually called sinusoidal, this type of behavior, because of the fact that it's a wave like this. Okay, so this is one period of sine. And if you kind of recall the unit circle values, right? Some unit circle values, like let's think back to like at the first radian value like this, okay? Hopefully you guys recall that that is, oops, let me do it like this. So I kind of just zoomed in on the picture here for the unit circle, and the first unit circle value is at, after 0, it's at pi over 6, right? And if we recall the left-hand trick, we can put down our ring finger and see that our coordinate is going to be radical 3 over 2, comma 1/2. So if we think back to the approximating values, okay, for the unit circle, pi over 6, take a second to think about what that would be as a decimal. So hopefully you guys are thinking pi is about 3.14. So 3.14 divided by 6, that's about a half. So it makes sense that at about a half, we're just at about a half. Okay, actually it should be a little less than a half. We're about a half. And it makes sense that that coordinate is there. Okay, so it's increasing from 0 to pi over 6. It reaches its maximum at pi over 2, which is where it is on the unit circle. And then on the opposite end, let's recall from symmetry that we're going to have negative radical 3 over 2 and then positive 1/2. So if we kind of, again, think about what 5 pi over 6 is as a decimal. So kind of do some mental math. 5 pi over 6, so it's about 5 times 3 is about 15. 15 divided by 6, that's about 2.5. So if we recall, pi is about 3.14, so therefore our coordinate should be about 2.5, 1/2. So it should be somewhere around here, right? A little bit to the left of pi, and that's why we have that coordinate there for the sine graph. And the pattern will continue as we continue going around the unit circle. But I wanted to at least illustrate a couple of the coordinates as to why the pattern of the sine graph is that way. And what we can do is, because it's kind of going to be a cycle, right? At -2 pi, we're also going to be at 0. At -3 pi over 2 is essentially going to be the same thing as pi over 2, because that's its coterminal angle. At pi, negative pi, we're going to be at 0. At negative pi over 2, that's coterminal with 3 pi over 2, so we're going to be at -1, and then obviously we're back to 0. So this is 2 periods of the sine function. Okay, so now let's go over the characteristics of the graph of sine. I'm going to zoom out a little bit here, and let's type in the characteristics here. I'll actually just write them out. So the domain for sine of theta is -infinity to infinity, because I could sub in whatever value I want for my radians, and I'm going to get an output. Okay. However, there is a restriction for my range. It'll oscillate between +1 as my maximum and -1 as my minimum. So it's going to be close bracket, -1 to 1, and then close bracket again. All right. The amplitude, if you recall, is, again, it's the distance from the midline. So the midline is at 0, midline to max, or midline to minimum. So the amplitude for the parent function for sine is 1, because it's 1 above the midline or 1 below it. The period, if we were to slice up this curve so that way we can see one full wave, one full cycle, it's 2 pi units. And remember, for the even or odd, this is talking about symmetry. For the sine parent function, this is going to be odd, because there is symmetry about the origin. Okay, and the way we could tell, again, if you recall the function definition for odd symmetry, x, y for odd functions will have -x, -y. So, and I'll write recall here. So for our example here, right, at pi over 2, we're at +1, -pi over 2, we're at -1, and I'll highlight it. Let's do it in yellow. It's odd because of pi over 2, 1. And then if we were to switch the signs of both of them, we would have -pi over 2, comma, -1. All right. So we went from both being positive to both being negative in terms of the signs of the function. Basically, it's you're changing the sign of both of the values. All right. So these are all the key points for our sine function.